again, everybody. I'm Dave Thomas, and today I am building the Adventurer from Madcow Rocketry. This is what they call a warehouse kit, which means it comes with all of the fiberglass parts, but it does not include any recovery hardware or motor retention hardware. You have to supply those yourself. It also doesn't come with any instructions, so it's a good idea to already have built quite a few model rockets, and preferably even some fiberglass ones, before attempting this particular kit. This is meant to fly with high power motors as a 38mm motor mount. It probably would fly on a G if it's a high thrust G, but this is something you're going to want to have your high power certification to be able to fly like it should. Since this is a fiberglass rocket, we're going to need to wash everything, and I've actually already done that, but either put all the parts into, say, a bathtub or a big basin of soapy water, just regular dishwater detergent will do, or you can make a spray-on washing solution that's half rubbing alcohol, half water, and then for every pint, or roughly 500 mils, add a drop of dishwashing liquid. Okay, and then you can spray that on and then wipe it off. Remember to do both the insides and the outsides, because the oils that are used in the forming process can interfere with the epoxy that we'll be using to glue all this together. Okay, so the parts we have here, the main body tube is pre-slotted for the fins. Then we have the payload section here, and this can be used either for an actual payload or you can set this up for dual deployment. We have the coupler here that will go between those two body tubes, and then this is the coupler tube itself that goes over like this, often called a switch band, because if you're using electronics in here, often you put a hole through this, and that's where the power switch for your electronics are. Okay, and then we have a nose cone that's got an aluminum tip, and the nose cone coupler, which will fit in here. Alright, and finally the 38mm motor mount tube. Alright, then we've got 3 fins here with fin tabs that will go into those slots. The kit comes with 2 centering rings. I actually asked Madcow to include a 3rd ring, and they did that for me at no charge. I was really thankful for that. But that's also because this kit is one that they make up on demand, and so they don't just have them laying around all the time. When you order the kit, they actually bring all the parts together and then send that kit to you. So that wasn't too hard for them to do. And then we've got some bulkheads here. 2 of them have cut shoulders into them, and these will go into the main coupler here to form an avionics bay if you want it. And then a 3rd bulkhead will go into the coupler for the nose here, and that will form the basis of the entire nose cone attachment. Okay. Now, you will also need to have some sort of motor retaining system. I haven't quite decided which one I'm going to use, but I really like the screw-on systems here. So I've got an Aeropack aluminum one that will fit this, and then I've also got Launch Lab Rocketry's polycarbonate retainer. This one's a little bulkier, but it is also a little bit less expensive. As I recall, this one's about $24, and this one's about $17. Okay. There really isn't a lot of room in this for using Z-clip type retainers that do work really well on bigger diameter rockets and are very inexpensive, but they just won't fit on this one. You could friction fit the motor, but I just don't recommend that in general. I prefer something that's got more positive control over the motor so it doesn't move at an inopportune moment. Okay, so with that, I'm going to move most of this stuff out of the way, and we will start on the build. Now, in general, it's okay to handle finished surfaces like this bare-handed, but anytime you're going to be coming in contact with raw fiberglass here, so any place we've got a cut edge, I really recommend wearing gloves so you don't end up with little fiberglass splinters in your fingers. on some of these edges that will be exposed, you can take a little bit of super glue and just lightly run that around the edge. And this will simply bind any loose filaments together. And then after this dries, and with a really light sanding, it'll give you a nice finished edge. And you don't have to wait for this to dry. In fact, I don't recommend it because, as you can see on mine, it's trying to run. So just take some tissue or paper towel here and just quickly run that around to absorb any excess. And the rest of that will dry really quickly. Okay. I'm going to do the same thing over here on the forward edge of my main body tube, because this will be open when you're doing things like packing the recovery system. In the same way, just really quickly wipe that off. Alright, and then you can also do it to the payload section. Okay, and once this is completely dry, give it about 20 or 30 minutes, you can use some very fine sandpaper, say about 400 grit, to just lightly sand around there, and that should take off any remaining fibers while keeping the base of those fibers locked in place with the glue. And it'll just make it easier later on to handle your rocket without getting splinters. Now for the next part, we're going to generate some splinters. And it's a good idea for this to wear a mask along with gloves. So just a regular dust mask is fine. But any place that we're going to have epoxy, we're going to roughen up the surface a little bit to give it a good place to grab. And for this, use between about 60 and 100 grit sandpaper. And so I'm going to go around all of the fin slots here. Now you don't need to do a lot, and you don't need to go very wide. But this will give something for your epoxy fillets to grab onto better than a completely smooth surface. Alright, same thing with your fins. Go ahead, and you only need to do this along the fin tab here and just beyond it. So I'm going to get, alright, so that corner right there is the depth of my fin tab. So if I go just above that, that's where my fillets are going to reach. Alright, and then also our motor mount tube. Now you won't know exactly where your fins are going to end up hitting in here, or the centering ring, so I just recommend doing the whole thing. We do have rough edges here, but once this is mounted in the rocket, the forward edge will be out of reach. You don't need to worry about it. The aft edge will have a motor mount retainer on it, so that will also be covered. So here I'm just going to quickly sand the entire length. Alright, and now I'm going to take a paper towel or some tissues here. I'm using tissues. And you can either use just some regular water. I use alcohol because it evaporates quickly. And just wipe off all the potential sanding dust here, off all the things that we just sanded. so we don't end up with it in the air or in our fingers, etc. Alright, next I'm going to start positioning rings for the motor mount. And one of the things I want to check here is whether or not the motor retainers will actually fit the way I want them to. So this is the Launch Lab one, and it actually is a little bit larger than my body tube is. It would work, but it would have a lot of drag going over that. So that's going to leave the R.E.A.R one. Alright, and I think this is actually made for a cardboard motor mount. It'll still work, I'll just need to add a little bit more epoxy to it. But it is much narrower, and that's the advantage of the R.E.A.R one. Even though it costs more, it's because it is made from aluminum, it's stronger and thus can be smaller. Okay, so if we just take that off, alright, which means we need to have that much in there, so it needs to stick out about ½ inch. Okay, which means we can make the motor mount tube flush and still have enough room between the centering ring, which is going to go here, and the aft end of the body tube, so that this can be put on. Okay, so I'm going to dry fit these. Something else we'll need to consider is how we want to mount our shock cord. Since there's not a lot of room in between my centering rings here, we'll probably have to do something a little bit more like what we do in mid-power rockets. Alright, what I want to do here is just have this line up next to the slots here. So you may not be able to see that slot very well anymore, but I can see it here, so I can use it as a guide. I do need to let the motor mount come out just a little bit. Okay, so we'd have one ring there, and one ring about there, and then the third ring up here. Now the reason I usually get 3 rings is that in most of these rockets the fins aren't quite these long, or the motor mount is longer, and so you actually have more distance between the forward 2 rings. And what I like to do is when I put this in, I'll glue in those first 2 rings first, but then leave off the aft ring so that I've got access to the fin tabs inside there, and I can apply internal fillets. Okay, I will probably still do that with this one. It's just that if you've got these 2 rings spaced further apart, you don't have to have this one in place. I'll have to put this one in place and put some little holes in it so I can pull it back out after this has glued into place. Once the epoxy's in place and my forward centering rings are glued in place, then I can remove this one, put the fins on, and do all that kind of stuff. And then put it back on when we're done. Alright, so the first thing I'm going to do then is mark this. Alright, so that fin needs to be right about there. Or that ring to accommodate the fin. Okay, and then my forward ring I'm going to put almost flush up here. Now for my shock cord, I am going to use some very heavy Kevlar. Okay, so this is 200 or 2,000 pound test Kevlar with a working load of 400 pounds, so this should be more than enough for this rocket. And what we'll do here is kind of like you do in a lot of mid-power rockets. We will put the shock cord underneath the ring here, So I'm going to have to file out a little bit of the centering ring, and then we'll wrap it around the inside there and then glue the whole thing in with a bunch of epoxy. Okay, and then we'll have this long enough to extend out and then just put a loop in it. So this is not going to be very long initially, and that way we can attach a more interchangeable piece of shot cord, whether we use nylon or Kevlar or something else, to this base piece. Okay, so what we're going to need to do here is a little bit of filing. Alright, so this is a round-faced file. Okay, so, yep, that should go in quite easily there. Now first I'm going to take some masking tape and run it around my mark there. So go from there, and this will just give me a nice straight edge, straight-ish, so that this will go on and not go down any further. I'll give a little bit more there. One of my viewers suggested this, and that was a really good idea. So instead of having to eyeball whether or not your rings are perpendicular, you can do it with the tape first, which mine's trying to creep around there. And that'll give it a buttress there to stop at. Okay. Now for this, I recommend using 15-minute epoxy. In general, the longer the working time, the stronger it is at the end. Now even 5 minutes is probably strong enough for this, but it just gives us a little bit more working time. So I've made up some 15-minute epoxy, and the first part I want to go here is a very small amount right up to my masking tape there. I actually don't want a big fillet on the aft side of this because it could interfere with the fins. So once this is in place, I'm going to remove that tape and take any excess epoxy with it. Alright, so I'm just going to kind of twist this down until we get onto there. And you can see there's a lot of epoxy building up. So we'll remove that with the tape. Okay, but I do want a good fillet on this side. Okay, and you don't need to smooth it in, though you can if you want. If you do want to smooth it in, what I recommend is taking a rubber glove with good tight fingers, moistening that with a little bit of rubbing alcohol, and then use that to smooth it around. And the rubbing alcohol helps keep it from sticking to your glove and building up. Okay. Again, we'll just put that right against the tape. Now for our shot cord here, okay, so we're going to use, just for safety measures here, about 4 feet. And again, this won't be the total length of the shot cord, this will just be the mounting side. Alright, so I'll cut this, and I'll probably have to immediately change my knife blade. Alright, now I do recommend putting a little bit of super glue on the end here so it doesn't fray more. And you can immediately wipe that off. Alright, so now this is going to go through the forwardmost engine ring. And that is going to go on here. Now I haven't epoxied anything yet. I want to make sure I've got my lengths right. And this needs to go around at least halfway. You can make it go all the way around if you want, which I'm going to do. Alright, so that's going to go all the way around underneath there. Now I don't want it to bunch up again, so I'm going to pull that just a little bit more. Okay. Now here I'm going to back my ring up a little bit first. And we'll put epoxy around this, and then that's going to get pushed forward. Alright, and this is another reason why it's good to have the 15-minute epoxy. If this were 5-minute epoxy, I'd have to make up two batches of it. Alright, I'm going to push that up into the epoxy there. Not quite flush, but close to it. And now I'm going to put epoxy behind the ring. That. Okay, and then I'm going to take the free end of the shock cord here and wrap that around. Alright, this part's going to get a little messy, but that's okay. Now try to keep epoxy off the edge of the ring here, but we want everything nicely embedded down into the epoxy there. Alright, and all this stuff's trying to move around. We don't want that. Alright, so now I'm going to take some masking tape here, and it's not going to want to stick. That's okay. We just need something to kind of hold everything in place just for a few minutes. Okay, so now I'm just going to let this cure for a few minutes, and once it's got to the point where it's no longer flowing, I will remove the bottom tape there. So my epoxy has been curing for about 10 minutes, and I think we should be able to remove the tape here. You don't want to leave it too long or it'll become permanent. And it's usually best to do this with gloves, but it's really hard to grip the tape with it. In fact, this may have been a little too long. Alright, so it looks like we've got some epoxy here that's actually glued the tape. And we're going to want to take that out. As you could interfere with the fins. Alright, the rest of that should be fairly inconsequential there. So this needs to completely cure before we continue work on it. On the third ring, I've drilled a couple of small holes opposite each other here, and I just made a loop of string here. This is actually Kevlar, it doesn't have to be on yours. But what we'll be able to do with this is temporarily put this onto our motor mount, place the motor mount in while we epoxy the forward two rings into the body tube, and then once those have dried, we'll be able to just pull this back off again. The epoxy on the rings has cured, and so now I'm going to take my shock cord here and I'm just going to run it down through and into the motor mount just so it's out of the way. Alright, now to get ready to put it in, first we're just going to do a dry fit here. Make sure nothing's getting in the way. Alright, so that needs to go all the way to there. Okay, and that's showing just a little bit beyond flush there. Okay, we may have to bring it back just a little. And we can test fit a fin here. So if we move that fin all the way back, okay, then we can move our tube a little bit farther back. Alright, now I'm going to go ahead and put on the third ring here. Remember, it's not going to be epoxied yet. I'll go ahead and push that back in. I'm going to put a fin in. I'm going to turn this because that string may get in the way of the fin. So if I put it on this side and put in the fin, okay, what I'm trying to do is get the ring and the tube, everything else to be in there at the same time. Okay, now I'm just going to tap that down in there. Alright, so that's about where that third ring should go. And now if I test fit my motor retainer again here, alright, and that has enough clearance. So that's about where we want everything. Okay, so for the moment, we can go ahead and pull this back out. And we're going to need some more 15-minute epoxy. I've made up some more epoxy, and for this we're going to need a long dowel or other type of applicator so that we can get the epoxy up here beyond the fin slots. And this will tend to be messy, so make sure you've got a protected surface here. And we want to try and keep epoxy out of the rest of the tube. Now, fortunately, with the fiberglass, you can kind of see where it's going. Now I'm going to go ahead and push this in. Right, as we reach the epoxy ring, I'm going to turn it to help distribute the epoxy. Okay, now, once again, I'm going to go ahead and use the fins here as guides for the final placement. We'll go ahead and put them all in. Okay, and now I'm just going to pull back a little bit just till we reach the fins. And now I'm going to put my ring back on. And it doesn't even have to go all the way in at this point. It's just going to keep the motor mount stable and parallel with the body tube here. Okay, so I'm just going to let this stay on its side while the epoxy cures. While we're waiting for the motor mount to cure, we can start working on the nose cone here. And the first thing I want to do is just push this in until it stops. We don't need to push it really hard. And then I want to draw a line here so we know how far it's going in. Okay, and that goes that way. Okay, now I don't want to put this in permanently. You can, if you want, you can simply epoxy this into the nose cone itself. But I like to leave some flexibility here. So first I'm going to measure how far in that goes. Alright, so just over 4 centimeters. And what I'm going to do then is I'm going to hold this in place using plastic rivets. And that will allow me to disassemble this if I need to. Because, for example, you got a lot of space down in that nose cone, and a payload could go in there, or a locator could go in there. I've actually had a suggestion from a Rocketeer friend of mine to just fill this with instant foam, so that if a rocket lands in a water body, the nose cone at least will float and you can pull the rest of it out. And that kind of situation actually happened to me a couple of weeks ago, where we lost a rocket that was very similar to the one I'm building now, because we couldn't get to it before the whole thing sank in about 12 to 15 feet of water. We're going to try and get it back later, but it would have helped if there had been something floating that we could have grabbed. So now I'm going to take a tape measure here and measure all the way around to see how much circumference we have. Okay, so this appears to be about 18.3, which means if we use 3 rivets, we can put each one at 6.1 centimeters. Now the problem is, if we move this up a bit, I don't think that it remains parallel there. It might. Actually, it's pretty close, so that's okay. So this nose cone has a bit of a straight bit at the base. Okay, now holding that in place, I'm going to take a pencil first of all and mark this from the beginning. Okay, so keep that as taut as possible. Okay, so it's 6.1 right there. Okay, and then at 12.2, which will be right here. And then all the way around at 18.3, which will be right here. Okay, now I can take that off. Alright, now I can just barely see those. So now I'm going to use a tube marking guide. Normally you use this for model rockets for marking the fin. I am going to draw, or hopefully, some straight lines here. Okay, so we've got 3 lines going up, and now I'm going to measure up 3 centimeters on each of them, and that's where I'll put my holes for my rivets. Now if you get these perfectly aligned, it won't matter which direction the nose cone and the coupler are in. If you don't get them perfectly aligned, it'll still work. It just means you have to get the exact holes lining up each time. Alright, now I'm going to put the coupler back in so that when I drill these, it'll go through both the nose cone and the coupler, and that way those will at least be aligned regardless of where they are going around the circumference. So I'm going to go off camera here and do this and then come back. Alright, so these are 5 millimeter diameter rivets, and these particular ones are 6.5 millimeters long, and I'll probably be using this throughout the rocket build. Now since my drill bits are all American sizes, it takes an 11/64 inch drill to get the right sized hole, and I recommend actually starting with a 1/16 to a 1/8 as a pilot hole, and then do a 3/16, which is just below this size, check it for fit, and then go up to the 11/64 if you need to. Alright, but these should all go in now. There we go. Okay, and so when you push these down, it expands the piece that's inside and locks it into place. Now I'm not going to do that quite yet because it's really hard to get them back out, but not impossible. And that's the whole idea here. Now you can see we've got little fibers in here, and so I'm going to take this back apart. I am going to mark it here so I know where to align it again. And one of the things we can see here in just a moment is how close we got them. So if I got these perfectly spaced, if I turn it to the next one, they should all line up. But they don't, so I didn't get them perfectly spaced. It happens. Okay, so to fix this, we'll do just like we did at the edges of the body tubes, and just put a little bit of super glue in there. And we'll let that harden, and then we can just cut that stuff away with a hobby knife. But we want to make sure the rest of it's anchored in place. And if this stuff runs a little bit, it's not going to hurt anything. Alright, now in the outer ones here, the only bad one is right in here, so I'm just going to put a little bit of super glue on that to stabilize it. And go ahead and hit the holes here. Now we may have to come back with a drill or a small file and reopen these if the glue is too thick. set that down and glue it to my mat. Okay, and then here we'll just go ahead and wipe off the excess. Alright, once this is painted you won't be able to see that stuff. Alright, we do want to make sure we do it on the inside too, because if we have a lump of glue in there, that could interfere with the nose cone coupler seating properly. I misspoke just earlier here. This should be a 13/64, which is just a little bit bigger than a 3/16 inch drill bit. Okay, sorry for the confusion there. This is the bulkhead plate for the nose cone, and I'm going to drill that to fit a 3/16 inch eye bolt here. So I will do that off camera as well and then come back. So now I have it drilled, and this does not have any bevel or anything to it, so it can go in either way. And what I'm going to do here is we'll have first a nut going all the way up there, and then a washer. That's going to go through the bulkhead plate, and another washer, and another nut. Okay, now when I actually get ready to have this permanently installed, or at least semi-permanently, I'll put some thread lock on this so that these things do not come loose. If you're sure you want to keep this permanent, you can put a big blob of epoxy all the way around this on both sides, and that won't be going anywhere. Okay, but first I need to install the bulkhead into the nose cone. And for that, we'll just epoxy it into place here. This time I'm using some 5-minute epoxy, as I really don't need the long working time here. And it's still going to be more than strong enough. Okay, so here I'm just going to quickly test fit it, make sure it does indeed fit the way it should. And what happened here is we got a little tiny blob of super glue right there. So let's take a little bit of sandpaper and remove that. I'm going to go ahead and roughen up the inside of this. Give us a little better surface. Alright, and now I'm just going to apply the glue right to the inside edge. Okay, and now we're just going to put this right on the inside. And I should probably be wearing gloves for this, but I'm not. Okay, and then I'm going to take my handle of my hobby knife here and push that up. Alright, so what I'm doing is making just a little bit of an too much indentation. This was working so well. There we go. Okay, so I'm going to trying to leave an even amount around there. Okay, so about like that. And with all that moving around, we've got glue on both sides now. So I'll just let that sit and cure. And then afterward we can add the hardware. Here I have the nose cone coupler and the epoxy on it's fully cured. And you can see here I've added thread lock to both sides of the eye bolt there. So that needs to dry, and I'm just going to set this aside for now. Okay, along with the rest of the nose cone. I won't actually assemble that until after I've painted it. Okay, over here we have our body tube with the motor mount installed, and its epoxy is cured. And so here I'm going to remove that aft ring so that we can get... For my fins, I'm going to round over the leading edge. Okay, and you'll definitely want to be wearing gloves for this, possibly a respirator mask as well, and some safety glasses so you don't end up with fiberglass in places where it shouldn't belong. Okay, so I'm going to start out with some 100 grit sandpaper, and I'm just going to knock over the edges first. Okay, now unlike when you're doing this with balsa or any of the hardwood types of fins, this takes a long time. Okay, so there I've got the basic shape, and I'm going to go to some finer sandpapers to smooth that out. Now on my tip edge here, I'm just going to sand that square, and then just get very slightly on the edges there, just so you don't have a knife edge you might actually cut your finger with. Same with the trailing edge. Alright, and then just check and make sure that it's even. So you can see I've got more sanding here than over here at this tip and this tip, which means I need to do some more. Okay, then I'm going to move on to 220 grit. Okay, so overall that looks pretty good. Go ahead and wipe that down, remove the dust. Alright, so that looks pretty good, and I'm going to do the same thing to the other two fins off camera.